1930s Germany. Science belonged to men, not to women, and certainly not to Jews. Yet one of the first people to truly understand what nuclear fission meant was Lise Meitner. She realized the uranium nucleus could be split, and she understood this wasn't just a problem of physics. Because if an atom were split, it wouldn't be only matter that divided, the world itself would. At the time, she was fleeing Germany, and one question stayed with her. What will this knowledge become one day? For centuries, people believed matter was indivisible. Even the word atom meant exactly that, indivisible. But the atom had a nucleus, packed with positively charged protons. Any proton sent toward it was pushed away. So breaking the atom was, in theory, impossible. Until 1932, James Chadwick discovered a particle with no charge. The neutron. It wasn't repelled. It entered the nucleus, split it apart, and released energy. A chain reaction. This wasn't a small explosion. It was the mathematics of a bomb. And if left uncontrolled, it would not stop. Lise saw this, and she stepped away. America invited her to join the project. She refused. I want nothing to do with this bomb. The Manhattan Project. This was not the decision of a single person. Oppenheimer was only the face. The decision had already been made. In 1939, Leo Szilard wrote a letter to Albert Einstein. His idea was simple. If a chain reaction is possible, we must do it before Germany does. Einstein signed the letter. It was sent to the US president. And a theory was no longer just a theory. E=mc superscript 2. Mass could be turned into energy. Thanks to the fission Lise explained, this equation became reality. At Los Alamos, the world's brightest physicists gathered. The clock was ticking, and one terrifying question remained. What if the chain reaction doesn't stop? Some calculations suggested even the atmosphere could ignite. They calculated again and again. Enrico Fermi, Edward Teller. On paper, the risk seemed acceptable, but no one was truly certain. They weren't building a weapon. They were building a possibility. And using the bomb wasn't inevitable. Germany was close to collapse. Japan could have been defeated slowly, but without it. But a new reality emerged. The Soviets were also chasing fission. So the world had to see who held the power. In 1945, the decision was made.
An American airplane dropped one bomb on Hiroshima and destroyed its usefulness to the enemy. That bomb has more power than 20,000 tons of TNT. It is an atomic bomb.
Hiroshima, little boy, 15 kilotons of TNT. Nagasaki, fat man, 20 kilotons of TNT. The atom split. Energy was released. 2 cities were erased. Nearly 500,000 lives were changed. Tens of thousands died instantly. Tens of thousands more died in the years that followed. This was not an ending. It was a beginning. Humanity realized something new. If we can split matter, we can also combine it. Fission splits atoms. Fusion joins them. What the sun does, and the power released, was more than 500 times greater than a fission bomb. Ivy Mike, the first hydrogen bomb.
3, 2, 1,
Today, these weapons are held by multiple nations. And the system is simple. If one fires, the others fire too. This time, there is nowhere to hide. After the war, they asked Lisa, "How do you feel?" Her answer was brief. A deep shame. On her gravestone, it reads, "A physicist who never lost her humanity." Despite the Nobel Prize she deserved but never received. Years later, Einstein said, "The only great mistake of my life was signing that letter." Oppenheimer, meanwhile, told President Truman, "Mr. President, I feel I have blood on my hands." The response was cold. That blood is on my hands. In 1945, the world listened to those who said, "We can." Today, the knowledge is still with us, the power is still with us. The question is not what we can do. The question is, this time, who will we listen to?